Well, ladies and gentlemen, technology is hard. I just talked for a long time about my struggles with pickups without realizing that my audio was off. And also, my mouse still bugged, a little bit bugged. I'm hoping that today's fix or tomorrow's fix or whenever the VTube Studio update comes fixes some of the tracking issues I've been having. Hopefully. As you can see, I can only wink one eye. That's not deliberate. In fact, I'm actually quite upset that the other eye is not following my commands no matter how hard I try. That's really irritating. Whoops. I'm not quite sure what happened there. But anyhow, don't mind me winking. Right, where was I? I was talking about my troubles with pickups. Viewers, if you go through the archives, you'll see that I have actually tried to do a live winding of a guitar pickup before, to some disastrous results. It's not as if using a drill doesn't work. It's that the way I had it set up and everything was very slapdash. Everything was basically made what I could find in the garage, just lying around as like scrap wood, cardboard, and everything else. The reliability was not there. To put it lightly. To put it more seriously, the thing was a piece of crap. So what I did was, I didn't really tear it apart because there was nothing to really tear apart. What I did was order a whole bunch of custom parts to put together into a proper pickup. Now that does require me to do a couple things. Let me see. Where is the air droid? Hold on. I'm missing my live cam. Where'd it go? System nearby. Hello. Hold on, folks. My camera went down. This is so annoying. Oh, remote control. That's right. Remote cam. Right. So I got a whole bunch of custom components to actually make like a proper version of the pickup winder. There we go. There we go. So yeah, everything you see before, other than a drink, of course, is parts that will be useful for making a proper pickup winder. Now, why am I making this instead of just like buying pickups? Because for this this particular project that I'm making, that I'm really proud of, actually, it's starting to take shape and look actually pretty good. I need custom shaped pickups. I can't simply use off-the-shelf components because nobody makes off-the-shelf components for the thing that I'm trying to make. Is a 7-string instrument with wildly divergent string placements. Well, no, not wildly divergent. You're not imagining some kind of crazy monstrosity, but it does fan out for what is effectively a guitar, like the equivalent of a guitar neck width on one end to something much, much, much wider on the other. And there is no pickup on the market that's over a foot long, especially not a 7-foot pickup. Even then, I probably still need to split it up into like 3 and 4 pole configurations in order to have it match properly. But that's a total aside. Once you actually see what I'm making, you'll understand. But custom shaped pickups, custom shaped pickup guards, and everything else. I pretty much have to do pretty much everything by scratch. With the benefit, of course, that I do have access to a 3D printer now to do some of the heavy lifting for me. That's a very, very good thing. Actually, I really love my 3D printer. It's a lot of fun. I've made so many little tools with it. Like this, for example, is a pickup winding jig. what you do is attach the motor port to one end. You clamp the pickup to the other, and then it just spins in place until you have like 5,000 rotations, and then you're done. So far, so good. But that also means that you need a proper motor. You need to have a heavy enough base to sustain operations without everything flying apart. You need a way to count the number of windings you've done, and a way to control the speed of the motor as well. So I need to measure out all these little components. Oh yeah, also like a power source that I can plug into the wall and have it work. So I need to measure out the proper size of everything. Make sure that they attach properly to everything that I'm trying to build. Make sure that when I plug in it doesn't tear itself apart under the torque. A bunch of little things. But the main thing is like, what does it actually mean to like put together this motor with the clamp, with everything else? Actually, does it even fit properly? No, I will need to drill this out a little bit. So I'll need to figure out approximately the size of the screw head over here, which won't be hard, and like a small screw on top to like clamp it properly onto the motor tip over here. And before everything else, I also need to figure out like, actually, yeah, the first part, of course, is to visualize. No, not visualize, but like conceptualize like what the actual like pickup, pickup housing looks like, right, and how everything's going to fit together properly. And there are actually a lot of websites with specifically instructions of how to do so, like step by step. What you need to carve out. Here are the CNC files to carve out the bits of wood, or if you're using a 3D printer, like what the 3D. Well, no, actually no. Here's the thing. I looked it up. There are no 3D printed diagrams for the box components I need. At least not according to the way that I want to build them. So that too has to be customized. This thing is a lot of work. This project has taken me multiple weeks to put together and to make sure that I understand everything properly. It's definitely a thing. But yeah, let's put. So step one is to list out, like, partially list out the things I need to keep in mind, and then to like draw out exactly like how they're going to put together. So we need to have an engine block. No, not a motor block, not engine block. Pick up jig. Speed controls. Power. Tensioner. What else? All right. Counter. Yeah, I think that's it. Okay. So number one thing is, this is the shape of the engine. It's a very, very basic engine, relatively noiseless when it spins up, or at least it's supposed to be. You can feel that there are powerful magnets within. You can tell that this is where it's supposed to clamp against the wall over here. So let's do a rough, with my drawing skills, a really, really crude impression of it. Oh, that's just TikTok going off on me. Let me see. Let's see. Let's block over here. And that's where it's going to clamp against the wall. So at minimum, I swear the pressure knob is sometimes a little finicky. This Wacom's only about I want to say 2 years? No, it's only like a year old. Just remember here, that's where the connections are. And then goes up here. We have the nut. Nut. And then a bit of a nub screw block here. And this is where we start busting out calipers, because the most important thing to figure out right now is the minimum height that the engine block, the motor block needs to be at. And the minimum height is basically defined by the pickup jig over here. Obviously, it needs to be spinning at a rapid rate, which means it needs to be at least high enough above the floor or the table or whatever it's mounted on to get away with its torque. And roughly, I think the maximum height is roughly the size of the Allen nose jig here. Since I have to feed everything to Tinkercad, millimeters is probably the best way to measure this. And according to my calipers, approximately it says 95.9 there, so I'm going to round it up to 96 millimeters. Oh no, wait, that's not entirely. Well, no. Let me see. That actually is doable. 90. So approximately 48 millimeters height difference, or minimum, from top to bottom. .48 millimeters. And the overall length over here. Well, this is easier. No, it's not. This is the best way. Okay. Approximately 45 millimeters. 44 even. Well, let's call it 45. Okay. So from the base of the engine to the tip of the screw, let's call that 45 millimeters. From the tip of the screw to the lowest possible limit is approximately 48 millimeters, but we probably want that to be more like 50-ish. call it 55. Is that enough? Yeah. Call it 55 millimeters. It's kind of arbitrary. You can even make it infinitely high. Well, you can't really, but giving us a 55 millimeter height, so approximately 5 centimeters high, 2 or 3 inches high. Yeah, that gives us a pretty good clearance rate. And the hole over here will be 26 millimeters, give or take. I'll make that 26.1, so there's a little bit more clearance. Yeah. .27 millimeter. Clearance of approximately 3.86. No, 3.8. Okay. With the nut. How about without the nut? Screws on. Okay, so without the nut, it's a distance of 5.4, 5.6. Total width of well, that doesn't matter so much. What does matter right now is that I have a pretty good idea of what the interblock looks like. Oh, sorry, the motor block. I'm saying interblock. Let's see. It should basically look like so. Horizontal distance doesn't matter because all you need to do is make sure that it clears the bottom. Well, actually, no. Horizontal distance, there is a minimum involved, and that is the radius of the motor itself, or at least the diameter. That is a maximum of 51. No, that's a minimum of 51 millimeters. So let's make that 55. Yeah, 55 by 55. So we have a bit of a square going on here. Actually, 55 divided by 2 is so the total height of the box actually has a set parameter then. Minimum height of the box is approximately 83 millimeters. This is just on the side profile as well. Oh, that 32. That box to that end. Yeah. And so total length will be 64. A total size of 64 by 83 millimeters. And then this is the control panel side. All right, we have the initial parameters. It just doubles up on the 2 panels. So overall, the machine will basically look like a wooden block on the bottom for the base. And a spinny jig over here. It goes crazy. There's a guide rod over here. The wire goes up here, under to the jig. Oops. It just like goes crazy in one direction. And then there should be like a counter over here to read. That's simple enough. Yeah. Now that we have a rough, approximate idea of what this is supposed to look like, we can start implementing it in Tinkercad. Side tablet and all right, that's good enough. I have my notes. I have a rough idea of what's supposed to look like. I can start implementing it properly. Which initial shape is probably best? Well, start with the box. Grid. Each grid is how much? 10. So it's centimeter by centimeter each. How long are the screws over here? That actually determines of how thick I can make the walls. Let's see. There. So the side screw heights are approximately centimeter each. 5 I'll do it. 5 centimeters. I need this to be 64, I said. So 10, 20. There. using the base as the height. We now need circle of roughly, first of all, the height is 5. Tinkercad's very useful for just like very intuitive to use for basic configurations. It's supposed to be a circle. Total radius of approximately 27. Middle of the circle needs to be 55 high, so 2, 5. We got a solid for now. Increase the height a little bit, so at least it sticks out a little better. Actually, wait, what's 27 have? It's 1, 2, 3, 4, 5. Actually, that's about right. And it's supposed to be only a rough estimate anyhow, so it doesn't really matter that much. Shift click to combine the two, well, to highlight both of them and then group together. You have a hole in the middle of the plate. Good. Further details includes the spacing on the connecting bolts. That's 5.7 millimeters. Oops, didn't want to do that. I want to hold on to there. All right, so 1, 2. Click on this. Let's see. Moving this direction. That should be right, I think. Relative coordinates, I think that's correct. Copy, paste, and drag this one over here. And that's roughly right. It doesn't look like it's quite there, but there's only really one way to tell if this is the correct positioning, and that is to print it out and try to mount it. And you know what? If it doesn't work, that's not too big of a problem because I can just drill it out. Easy enough. Actually, it should be like a tiny bit smaller than 3.8. Let's see. That's a screw in. Connect everything. There you go. Now there are holes on the side. All right, good. Next part is also easy. All you need to do is add a triangle. And then just drag it out. Size only matters. I should however, make sure that the grid is properly set up. MakerBot, Ultimaker, Custom. I do not have. Let me go something. Ender. Uh, 220 by 220 by 250. Okay, so far so good. There we go. The engine mounts here. Now the thing is, what I've done here is build off on a side just to make it like easier to figure out for myself. But this is not the complete print. No, we are not done yet. This is merely part one of part one of 5. No, wait. Is it? 1, 2, 3, 4, 5. Yeah, there's bottom 6. Yeah, there we go. So theoretically, I can mount it on either end. But it's not going to quite work like that. Let me see. Oh, you know what? I forgot. This. The magnetic probe that links up to your counter. This is a read switch, basically. Every single time a magnet passes through this tip, it closes the circuit, counts +1. This is rated to, I believe, read up to like 3,000 cycles per second, maybe? No, per minute. Yeah, something like 3,000 cycles per minute. question is, where should it read? Where should the read switch read at? Okay, let me see. This is approximately 11.5. A little bit less or more depending on the width of the screw, but I'm comfortable putting it at 11.5. Yeah, that should screw on properly. And besides, there's the D's to screw on as well. Okay, first of all, I should actually cover these holes. Delete, 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 and then combine it. All right. So the engine only mounts on one side. The reed switch. Rotates 90 degrees. Oh, right. So this little cutout over here is where the magnet goes. I may have to order another one to replace the one I lost. From the center of the engine block to the magnet is approximately say approximately 31 millimeters. Or roughly there. There. That's where the reed sticks out. So that every single time it rotates, the magnet will trigger the switch will lead to the counter reads. Easy enough. Now obviously I will need an internal brace to actually hold up the engine. I can make it out of wood, but why do that if I can simply print it out? Here's the thing though. What's the damn radius on this thing? Well, I suppose that's not as important as the... Yeah, either way, the cylinder, since it is a perfect cylinder shape, it's not going to matter that much. Mostly I just need the diameter of the cylinder. which is approximately 51. Oh, right. I was thinking the length of the cylinder as well. So, and need a minimum length of 78. Do I have that here? Let me see. This is iPhone mode. 1, 2, 3, 4, 5, 6, 7, 8. Hold on, getting some stuff over here. 我现在忙。我说我现在忙。Okay, where was I? I may want to raise the minimum height a little bit. Yeah, that's fine. Am I designing this right? Call that 21 millimeters. From the center of the circle to the bottommost part of the engine is approximately 21 millimeters. Center of the circle to the bottom was approximately how much? 55, I think it was. Yeah, 55 millimeters. So 34 millimeter height. Dead center, right? Yeah, dead center. All right, approximately correct. The reason why I need this becomes a hole for the bottom assembly block over here. All this has to be is a brace. So and that ensures the stability of the motor block. So that's easily mounted. And then to finish that off, connect everything as a single piece. Yeah, there we go. We have the basics of the chassis of the machine now. In fact, I can even put on a roof at this point. Yeah. All right. So this, I think, will be one contiguous piece. And the panel over here that goes on top will be a separate piece, so that I can disassemble the engine and not have to like lift up the whole thing. And then the whole thing can simply be glued onto a wooden block. Easy. Let's go ahead and export this as a STL file, double checking Cura to make sure that it's a printable piece, that I haven't forgotten anything. Yeah, seems printable. Oh, except for one small detail on the bottom here. I see. This part. I'm not quite sure why it's thinking like this. That's alright. flush. Okay, now it's flush. What about top? Is it properly connected? It's not. That's also easy fix. Okay. Now I can select all, combine. Yeah. Now it's one continuous spot on bottom plate. I don't care too much about top plate as much. Yeah, much better. This looks like it will need support to print, or does it? Don't need some support. That's way too much support. Oh well, let me see. I can fix that. Intel, material, speed, travel, cooling, support. There you are. Generate support, check. Support structure, check. Support pattern, support wall line count. That should help. Okay. Make this 0 support walls. Make this zigzag. Let's try that again. I'll drop it by an hour at least. Let me see. What's the main hang up here? That's a very aggressive support. Yeah, it prints all the way through. What if I... So there's an art to 3D printing. Excuse me, got a little... Excuse me. Wow. Where was I? There's an art to 3D printing, and that you generally want to have the print itself be as trouble-free as possible, which means printing something on its side, something on its base, something's upside down, just so that there's as few supports needed as possible to make the print come true. And I think I can make this, if I were to rotate this, it drops it down to 13-hour print. But do I trust it to print out that giant curve? I think I do, because the overhang's not too intense. That's not too bad. Okay. Let's go ahead and save this to disk. There. All right, part 1 done. Part 2 is to build the front interface plate. That should also be relatively simple. Just tip to tip. Back this out a little bit. Make much taller. And then rotating until it fits. I think it's relatively pretty close to a 45-degree angle, right? Should be. It's not. Use 2. Drop down on top. Further, all the way to the bottom. And then drag out. So, oops. Wow, I really screwed this. Whoa, what's happening here? Okay, let's do this. Okay, so relatively right. I just want to make the width a little bit more than 5. Let's make it 10. No, too thick. Too thick. Let's make it 8. 8 millimeters. Nah, let's make it full centimeter. No. Too thick. If it's a full centimeter, it's too thick. What I want to do here, let's see. Yeah, turn this into a hole. Position it so that it overlaps with the hole. Combine. And there you go. In one easy step, you've made a cutout along the plate that allows it to slide easily and immovably into the side of the box. Nice and easy. Now, what I need to do is figure out a couple of things. Number one, where to position the counter box, or rather, how to position the counter box. And also, where to install Where is it? Ah, here. The speed controls. On, forward, reverse. This is very nice. It's also really cheaply made. Jesus. You can see here that has 4 screw holes to mount it with. And then this connects over here. Let's start at one point over here. It allows me to attach these speed controls right this. So this is maximum 0, maximum speed. 0 off, maximum speed. Good. Alright. Looking at this, what it's telling me, I should bring up back the body again. Oops. And cut further holes along the first to make this a solid again. The way I want it to mount is like so. Position to the left, position to the front, and the counter on top. I think that makes sense. Yeah. That means I need to measure out the exact height. Approximately 5 millimeters from the bottom of the screw to the base. Make that safe estimate though. No, it's not completely safe because there are little jagged bits over here that's going to get in the way. So what I can do, okay. The overall size of this is exactly 5 centimeters by 3.2 centimeters. Okay. inconsequential what size of this is. That's correct. Give a little breathing room. Turn this into a hole. Combine shape here. Then drop height to like 3. And that is how you make an attached tray. Move this aside over here. And this is, let me see. Yeah, this is solely to make sure that the controls have a place to sit properly. Seven. Well, it doesn't matter that much. It just needs to be centered-ish. Is the important thing. As far as I can tell, that is roughly in fact centered-ish. That should be close enough. There. That is where it's seated. Here's the thing. This is not built very well. The sides over here extend way out. I think they might even be... Yeah, it's tilted on an angle. It's actually further out than the size of the Switch, which will make installation of these a bit of a pain in the ass, honestly. .22 versus 21, so just like a millimeter's difference. Go with 21. I'm pretty sure I can squeeze this through. I'm just a little afraid that I might damage components by doing so. So that's a pain in the ass. But yeah. Alright, so that is the pickup machine body main. That's the pickup plate. Oh wait, no. Shouldn't actually beat this yet. Here's this again. I forgot. What I need to do was make sure that it had the cutout, right? I forgot to actually do that. Let me go ahead and turn this into a hole. Make sure that there's no overlap there. That's good. Select all, combine, copy this, retreat, 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 delete this, go to Shiny Jarv, complete, paste, and there we go. Now we have the pickup plate with the cutout included to make it easy to fit in. There. Make sure the grid is still at 220 by 220. All right. Two things I want to do. I want to be able to mount this at the front, and then I want to be able to mount this underneath. What's the best way to do so? Well, first let me remove these back screws because this plate only exists to basically hook the magnet onto. So I don't actually need that there. Let's see if I can uncover any holes to act as a mount. It is good to have a multi-tool. It's also doubly good when screws come loose really easily. Alright, so we have a slight problem. There are only mounting holes on the back. It's not a big problem, but it's a bit of a problem. Because well, I don't even need the mounting holes really, because this has a relatively regular dimension and it has a lip. So as long as I push it in and it's a firm grip, and since it's going to be at an angle, it's not as if I risk it suddenly tilting over, falling out. It's going to pretty much anchor itself into place. So all I really need is the maximum size on each, the maximum length and width that I can jam it in from. And that's why I have calipers. That's 60.35 by 35.5. 35 point. Let's call it 35.5. Wrong way. No, that was the right way. Combine shape and have a nice hole to push out, to push this through. Yeah. So far so good. So far so good. Next part, the switch. One point. Two. a little lower in the base, so I can just feel for controls here. There. And then there's one final detail that I almost forgot and really shouldn't. How to connect the power supply. The power supply connects right to, let's see. Well, the engine connects itself to control plate. Control plate then has another set of leads to the power supply. Just weather. Yeah, this will be easy enough. I have a bunch of like DIY cabling in the first place, so you basically just connect black and red over here to this, have this thing up to the back, plug this in from the back. Maybe even, yeah, and then plug this into the wall, and you have a working machine. Hopefully. Main question then is, how do I design it so that this just can plug in anywhere? So it doesn't exactly have a strong anchor point. I'm going to have to glue this onto something, aren't I? I hate that. That is by far the least effective option. And then I see that I have to do so anyhow. Okay, so front plate's done. Let's go back to the export STL. Go back to pick a binding machine. So there's actually another thing I'm missing here. I forgot to install a place for the rod. And this is just a really simple rod. Yeah, basically as a tensioner. Nothing complicated about it. Is exactly 8mm diameter. Good. With a tolerance of like, what is the tolerance difference? 25. Not bad. its positioning does not need to be particularly accurate. It just needs not to like bump into anything. I will say the lower the better, so it doesn't come into conflict with the box side otherwise. Yeah, that should do it. A little higher. A little bit of a safety margin there. There. Another Swiss cheese hoe. Okay. Overall, I'm almost done. What's still bugging me is where'd you put this? And I think the answer is squeeze it through as far as possible on the second lowest rung. This is 12.8 versus 13. Okay, so that is a good idea. With gentle touch because it's rubber. So approximately 12.8 versus. Yeah. All the wires on this side. And perfect. I'm pretty much ready to print this. Let me double check on Cura. Standard quality, has all the right holes in the right places. Level bottom, which is really important. I can't tell this over now because of the tray I printed over here, unfortunately. This might end up a really, really long print. Let's try tree. Cura is taking a while to calculate this. Interesting. It's still slicing. Okay, there we go. 13-hour print. Interesting. Because the tree did not form properly. That's why. Must be because the wall settings, right? Slice again. I wonder if I can further reduce some of the unimportant overhangs. Tree rents distance, tree support collision resolution. Switch from tree to normal. Zigzag. Keep zigzag, but support density. Here we are. Support line count 0 again. Support density 10%. Yeah, that does the job. It's still a 19-hour print, but it looks like it uses a significantly less material and calculation time. Yeah. All right, now to check the other file, front plate. Already did. Oops. Check the Cura on that. This is much more uncomplicated build. The 3-hour print. It's basically nothing. So the total time spent printing will be approximately 24 hours, which means I just want to split this up into a 2-day project. But otherwise, we have a functional project. We have all the components we need. We have the build plates. All you do is glue the main body onto a piece of wood, and we're ready to print. Shit, that's amazing. I've actually finished the project. I will probably upload these onto Thingiverse afterwards, once I've finished building everything. And I'll start with the plate build, because I can do that tonight. I can just spend all of tomorrow printing out the rest of this. Alright, and that's an hour and 43 minutes of demonstrating of how you can put together a, design and put together a guitar pickup winding machine. That's amazing. And as far as I can tell, it'll probably even work. Once I have everything printed out, I will then do another one of these streams, probably sometime early next week, to actually put together, glue everything together, and we might even put the pickup, wind it up, see how it goes. Other than that, thank you very much for following along. This was actually quite fun. I will see you all tomorrow for some Persona 5 Strikers. As always, eat well, my friends.